going to come later. But tonight we have Professor Ian Plimer, and I'll introduce him very briefly. Professor Ian Plimer, School of Earth and Environmental Sciences, University of Adelaide, is Australia's best-known geologist. He is also Emeritus Professor of Earth Sciences at the University of Melbourne, but he's become particularly well known in recent time due to the publication of Heaven and Earth, Global Warming, The Missing Science. Janet Grundy down the back has got some copies of the book. So I'll invite Professor Plimer to talk on the topic of the theology of climate change. He'll speak for about 30 minutes. We'll take questions and discussion and finish no later than 7 o'clock. Professor Plimer, you're very welcome. Thank you.
Well, ladies and gentlemen, thank you for coming. When I look back in time, we can see all sorts of evidence to show that climates have always changed. And those climate changes in the past have been far greater than anything we can measure today. And they've been far more rapid than anything we've measured today. And these climate changes are related to some features which are outside our control. For example, every 143 million years we're in a part of the galaxy where we got bombarded by cosmic radiation. That gives us many more clouds. That reflects light and heat. We cool down and we have an ice age. And we've had 6 major ice ages in the history of this planet. And over 5 of the 6 of those ice ages, we've had an atmospheric carbon dioxide content far higher than now. It's been up to 1,000 times higher. So immediately there's a disconnect between atmospheric carbon dioxide and global warming. And we've seen that all through the history of time. We also see that sea levels rise and fall all the time. And it's not the pathetic 1 or 2 millimetres that people are having conniptions about. We have real sea level changes, like 1,500 metres. And we've seen those in the past. We currently are in a period where sea levels go up and down, and that's happened for all of time. For example, we can see that sea levels have changed. We can go to the port of Ephesus. That Roman port is now 15 kilometres inland. It's now 7 metres above sea level. We can go to the ancient city of Lydia. Lydia is 4 metres beneath sea level. I've sailed over it. I've sailed over the streets and seen the town where coinage was first minted. Scandinavia had about 5 kilometres of ice on top of it. That pushed Scandinavia down. That ice is gone. Scandinavia has risen some 340 metres in the last 14,000 years. The same happened to Scotland, the poor old English. Scotland is rising. As a result, Eastern England is sinking. The Scots have their own parliament and the English have got a Scottish Prime Minister. I mean, that's a trifecta. So we see that sea levels have changed all the time. What has happened with Scandinavia rising is Holland is sinking. That counterbalance effect happens all the time. In Australia, we have many tidal measuring stations, and one of them, the tidal measuring station at Port Adelaide, shows the greatest sea level change in Australia. It's 2.38 millimetres a year. And we think, oh, by God, let's do the calculations 100 years into the future. But what that tidal measuring station is doing is it's measuring the sea level here, but it's actually sinking. Sea level's not rising at all. It's a measuring station that's sinking. Tuvalu, what a place to inhabit, because the floor of the Pacific Ocean at Tuvalu is actually sinking. It's not that sea level's rising. If we look in the Maldives, sea level has dropped in the Maldives relatively 20 centimetres since 1970. And we hear stories about coral atolls and how these coral atolls are going to be inundated by rising sea level. Well, this was an idea that was floating around in 1831. Charles Darwin wrote a book about it in 1842. Professor Sir Edgeworth David persuaded the New South Wales government to fund a drilling program in Tuvalu, drilling through the coral atoll, because the thesis was that we have a volcano out in the sea, it subsides, and as it subsides, a coral atoll keeps growing and growing and growing. And therefore, if you drill a coral atoll, ultimately you should find a volcano. Edgeworth David did this. He drilled 1,300 feet. It was a long, tortuous exercise over many years, and didn't find a volcano. The Japanese tried it in 1938. Didn't find the volcanoes. And eventually, This was done by the French, testing their Bikini Atoll site, and they drilled over 1 kilometre before they hit the volcano. And what that means is the volcanoes have been sinking and coral reefs have been growing and growing and growing. Coral reefs thrive when sea level rises. They die when sea level falls. So sea level rises and falls for a great diversity of reasons. We see that the Pacific Ocean basin is getting deeper and deeper and deeper. We have supervolcanoes in the floor of the ocean changing the shape of the ocean. That changes sea level. So there are many, many reasons why sea level rises and falls. It is not just due to expansion of water or melting of ice sheets. But if we look at the melting of ice sheets over the last few million years, we see there's a cyclical process that goes on. And this cyclical process gives us 100,000-year cycles. And these cycles are where we have 90,000 years of of cold and 10,000 years of warm. 90,000 years of cold, 10,000 years of warm. And as a response, sea level goes up and down by about 130 metres. And we see extremely good evidence for that. The last great cooling cycle, we could have walked to Papua New Guinea, and people walked from Papua New Guinea to Australia to Tasmania. Now, why you'd want to walk to Tasmania, I don't know, but people did it. And this is telling us that sea levels have changed considerably. We can see in Bass Strait what were old valleys, and there were fireplaces there. So sea level is changing all the time. Climates are changing all the time, and really it's an extraordinary proposition to put that humans can actually twiddle the dials and change global climates. Because we have massive ice ages due to where we are in the galaxy. The Earth's orbit is very variable. Sometimes it's almost circular, other times it's a little bit elliptical. And that means that sometimes we're close to the sun, where it's a bit warmer, and other times we're a bit further away, where it's a bit cooler. Now those cycles are every 100,000 years. We have cycles every 41,000 years, where the axis of the Earth changes very slightly. And it puts us closer or further from the sun. That gives us warm and cold periods. And then the Earth wobbles a bit like a top, and every 21,000 years we're a little bit further away from the sun. So those cycles are orbital cycles. We have solar cycles every 1,500 years, every 210 years, every 87 years, every 33 years, every 22 years, every 11 years. Now those solar cycles are pumping more or less energy onto the planet, and when the sun's really active it blasts away cosmic radiation. When it's not very active, we have more cosmic radiation comes to planet Earth. And as we sit here, we have 2 cosmic rays go through our brain every second. It's doing you the world of good, and this cosmic radiation is with us the whole time. Now if we get an excess of cosmic radiation due to a supernoval eruption or due to the sun being very lazy, then we have a cool planet. Those cycles are quite well established. Then we have other cycles. We have a Pacific cycle in the Pacific Ocean every 30 years. It changes from warm to cool. We have a tidal cycle every 18.6 years. We have tidal changes, and that has just finished pushing a whole lot of warm water into the Arctic. That led to ice melting. That sea ice melting was quite extraordinary in 2005 and 2006. That cycle has now finished and the sea ice is expanding. So we have these extraordinary events that have a combination with accidental events. One volcano can ruin your whole day. We've had some massive volcanoes in the past. We are living in a period of volcanic quiescence. It's been quite quiet since about 1912. But a big volcano can make a great difference to the climate. Not a pathetic Mount St Helens, which was only half a cubic kilometre of material blasted into the atmosphere. I'm talking about a decent volcano like Krakatoa in 1883. And that was 30 cubic kilometres of material into the atmosphere. And we've had those volcanoes have changed the weather and they've changed the climate, such as Tambora in 1815 that gave us the year without the summer following, or the 1470 BC eruption of Thera or Santorini. And that wiped out the Minoans. That led to a change in civilization from a Minoan-dominated civilization in the Eastern Mediterranean to the classical Greek civilization. That one volcano changed Western civilization. But they're only pathetic. We have supervolcanoes, and supervolcanoes can pump huge amounts of aerosols into the atmosphere. And these supervolcanoes exist above the ground in places like Indonesia, around the Pacific Rim, and we've had one of those explode some 74,000 years ago, and that was Toba in Indonesia, and we come back to that. But we've got super volcanoes lurking in New Zealand. We've got them in Washington State. But they're only the volcanoes we see. The bulk of the world's volcanoes we do not see.